So today we're going to be talking about catching cute monsters with immutable patterns from functional programming. And I'm going to do my best to make this as approachable as possible, because it's really not as crazy as a lot of people make it out to be, or it can be. There's really cool and fun, complicated things that you can do, but all these examples are going to be just using vanilla JS. I am using a couple features in the language that aren't implemented across all browsers currently, but they'll work in the most current versions of Firefox, Safari, and Chrome, and mainly in Edge. But we're not going to be using libraries, and we're not going to be getting into sort of the arcane. We're just going to be saying, like, how can I understand this concept of immutability, and how can I start leveraging it today in my programming? And so the three things I want us to focus on are cute, because you're all cute. I said it, it's true. Immutable and functional. And I want to deliver on these promises, so I'm going to start with a picture of my dog and me working on the talk. That's Linus. We were working hard, and that was fun. Okay, so this was already kind of talked about, but I do also want to point out that I am also a volunteer for a couple of organizations. One is the Utah Refugee Education Training Center, and we are always looking for more boots on the ground to mentor and help teach. And so if any of y'all are interested in that, there are web dev courses and Java courses, and so come talk to me. I'm also a volunteer for Provo Pride. We just had our 5th year. It was at the Utah County Historic Courthouse. We had about 5,000 people show up, and that just happened on Saturday. So I'm like just all kinds of happy right now. Also, I am available for freelance. So if you want to build something or have me build something for you, hit me up. Okay, so about the presentation, we're going to demonstrate mutability and object-oriented programming. And we're going to use that so we can contrast with how we can accomplish the same tasks in a more functional paradigm. We're going to keep it fun by focusing on cute collections of cute monsters. And we're going to use vanilla JavaScript, and we're not going to get too serious or dogmatic, because nobody needs that. So our manager or our friend or whatever comes to us and gives us some requirements for an application. We want some code that is going to help us manage collections of cute monsters and allow us to test our abilities as trainers on the field of battle. And so what I like to do when I'm presented with a problem like this, and I want to accept the object-oriented paradigm, is I start sketching out classes and how they're related together. So here I say, okay, well, I know I'm going to have a monster class. I'm going to give it a name, a level, a type, an SVG, because I want it to be pretty, and a method to level up. And then the collection is going to have a monsters property that is going to have many monsters. And then the trainer is going to have a name and alignment, because I need to express that I am chaotic evil in this particular instance. And also a collection of monsters. And then we get to the final class here, and this is always where things get a little bit harder for me to figure out exactly what I think the right way to do is. When we're talking about a monster or a person or a car, object-oriented programming seems like pretty clear-cut. I'm like, I'll have a car class, I'll have a person class. What happens when I need to encapsulate some kind of behavior in a class? It gets a little bit more shaky, but I decided that I'm going to have a battle class, and the battle is going to have 2 properties on it. They're both going to be trainers, and it's going to have a method winner, and winner is just going to return a string saying who won or if it was a tie. So let's go ahead and take a look at some code. I'm going to do a little bit of a mixture of doing some live coding, which I'm absolutely terrified about. I don't always do the best at it in interviews or other situations, so this is a challenge for me. But I do have the backup of a bunch of it is written already, and so we're going to start just in the interest of time and my sanity in going over that. So I'm going to start with the monster class right here. And let's bump this up a little bit. Is that readable? And boom. Okay, so pretty straightforward stuff here. We create a class. The class has a constructor. And the constructor just takes in these 4 properties. Name is going to be a string. Level is going to be a number. Type is going to be another string, and SVG is going to be the actual SVG element that we're importing. And then we have this level up method that just says, take the level property on this class and increment it by 1 and set it back to itself. So pretty cool. And then we've got a collection. And the collection here, we import the monster, because the collection needs to know about the monster class. Because we're going to import these SVGs, so we got some pretty pictures to use. And then we don't want to like type out every single time we instantiate a new trainer. We don't want to be like, they get the same kind of starter monster pack, right? We want to make it one time and then give it to all of them. And so in our constructor, we say, okay, we're going to take in monsters, but if monsters aren't supplied, we're going to fall back to the default of the starter monsters array, which has these 4 cuties, and then sets it to itself. So again, pretty straightforward, I think. And then we get to the trainer. Trainer just has name and alignment, and sets a name here and alignment here, and then is going to just grab a new collection and set it to itself, so that for right now, we're just, every time we're going to leverage this, the new collection default parameters, so that every trainer that we create is going to have the same set of monsters. We could change that in the future if we want. And finally, we've got our battle class. And so battle class constructor has trainer 1 and trainer 2, and we're setting these properties. And then we have this winner method that goes through and it grabs the sum of all the levels that trainer 1 has. It grabs the sum of all the levels that trainer 2 has. And then if those two are equal, then we're going to say, because it's a harsh, harsh world, cute but harsh, that it's a tie, and when there are no winners, there are only losers. Not something I personally believe, but listen, we've all had to make compromises when working on projects for managers, right? And then otherwise, we have this just little ternary here that just sets, saying someone's a hero, the other person's a 0. Also, I must have been feeling a little bit harsh when I wrote this, but it's also kind of funny, so it's okay. Nobody's feeling, these are all, at least right now, abstract concepts. And so let's go ahead and check this out. I'm going to make sure that we've got Webpack running, and I'm going to bounce over to Chrome for this. Okay, so we're rendering some stuff, and I also am just going to take a little, just give you just a really quick top-level view at what's going on with the render, because this is all also just vanilla JavaScript, just kind of show you that, you can make stuff. It's a little tedious sometimes, and libraries exist for a reason, but you can do a lot with without importing any libraries and just creating stuff with JavaScript and throwing it on the DOM. So this is all just kind of vanilla JS, and the long and short of it is that our render function is going to accept 3 arguments. The first one is going to be a string that it's going to set onto an H1 element. The second one is going to be a string that it's going to set to a H2 element. And the third one is going to be a list of monsters that it's going to render out as little monster cards. So, moment of truth. We're going to try to start actually using that. So, I'm going to go back to, let's see, boom, boom, boom. This guy, boom, boom, boom. So I'm importing my code right here, and you can see that I'm rendering the title, catching cute monsters with object-oriented patterns, and that's showing up, so that's good. So what we're going to do first is that we're going to create a trainer, and that trainer is going to be me, and we're going to pass in the name Ryan, and as discussed earlier, chaotic evil alignment. Okay. And then we're going to go ahead and we're going to call our render function again, and we're going to just say Ryan's collection for the header, and then we're not going to give it anything for the second argument, and we're going to do me.collection.monsters. Okay, we compiled, and we've got stuff. Woo! Thank you. If anything else goes wrong, we can always just come back to this point in time when everything was perfect and we all loved each other. So we've got a collection of monsters, right? But that's not enough. We also need to be able to have an opponent, another trainer, and we need to battle, right? And so I'm going to go ahead and take a look at who I think I should battle, and we're going to start some beef with Drake. Unadvised, but mistakes of boldness, not timidity, right? Okay, so we're going to go ahead and create another trainer who is going to be Drake. And actually here, I'm just going to copy this. And Drake. And Drake. And then we're going to copy this and do Drake. And Drake. And we all know that Drake is lawful good. Common knowledge. So everything's going well. I don't know. Every time I see that GIF, he looks like he knows he's going to win a little bit more. But okay, so we've got two collections, right? We've got, and they're both the starters, right? Level 1, level 1, level 1, level 1, level 1, level 1, level 1. So if we battle these out by creating a new instance of the battle class, battle, and we pass in me, and we pass in Drake. Man, I'm feeling so cool being so close to Drake, even in just my own imagined universe. Next time I'll have to like put it out on Twitter to see who wants to beef with Drake, and we can see if we can make it happen for real. So we're going to go ahead, and we've got our battle, right? And then we're going to render here just the battle.winner string, and we'll pass in an empty string and no monsters here. And boom, boom. Oh, it's haunting me. Okay, and we get what we expect. It is a tie. When there are no winners, there are only losers. It's making me sadder each time I say it out loud. I'm sorry. Okay, so now I believe that defeat is unacceptable or tying. And so we're going to go back here. Now we just have my collection. And we're going to go ahead and take a look at some notes. And we're going to do some looping and take advantage of the level up method that we have. And so we're going to say for variable I equals 0, I is less than me, or we're going to level up 4 times, and I plus plus. And then we're going to have another loop because we want to level up all of our monsters. I is less than me dot collection j. Bless you all. Collection dot monsters dot length and j plus plus. And we're going to say me dot collection dot monsters j dot level up. And we're going to change our render to make sure it happens after so that we can see our results. And boom, we got some more levels. Woo! I'm so excited. And I'm so excited that we're not even going to render Drake. We're going to create a new battle. We're going to render the results of the battle winner and see what happened. What? It's a tie? How could this be? I leveled all my stuff up. I spent all that time grinding, and yet I have not won one bit. Okay, so let's do some visual debugging. Let's render Drake's. What? Drake's, has he been working as well? I didn't allow Drake any time in the code to level up. And okay, so now we have demonstrated the potential pitfalls of mutable code. And so let's take a look in the console here about what's going on. So I'm going to set a breakpoint here right at the end. I'm going to refresh so we get stuck here. Now we've got all of our values, right? I can start debugging a little bit. So I've got me, I'm a trainer, that's looking good. I've got Drake, Drake's a trainer, that's looking good. I want to see if I am equal to Drake. I mean, code could not be written that could make this true, but we're going to test all our assumptions because something wacky is going on. I'm going to try hard, but I will approach the greatness of Drake, but I will never reach it. So that's false, so that's good. So let's check out collections. Me.collection equals Drake.collection. Also false. What's going on here? We have to go one level deeper. Me.collection.monsters. Whoops. Me.collection.monsters, Drake.collection.monsters. True. So you can see how if it's easy to get lost like this, even this trivial kind of toy example, you imagine how complicated this can potentially get in large applications with many different engineers working. every time you make a change to code, even if you have a great test suite, even if you're using something, you've implemented Flow or TypeScript, you have to keep this stuff in mind that at any point, these variable references could be reaching out and touching the same thing. And I might be solving a bug over here and then introduce just waves and waves of unintended consequences in other parts of my application. And so now we're going to kind of talk about how we can separate this stuff out. And I just want to point out that, oh, yeah, how I feel. This is how I feel. I've got it? Oh, no. Yeah. I'm messing with one small part of the problem, and then another part that I wasn't even aware of slams down on my head, right? Everyone's unhappy. Okay. And look, I'm not saying that this problem is unsolvable in object-oriented programming. There are plenty of fantastic applications that are written with this style, and there are many, many techniques to deal with this. But expanding those techniques are not the scope of this talk. Instead, we're just going to take a look at what it takes to embrace some more functional immutable patterns. And so now I'm going to go into a little bit of techniques and some definitions. So what do I mean by functional? It's kind of a loaded term, right? What I want us to do is, if you remember that little diagram that I wrote, every time I start doing things object-oriented, I'm always thinking about classes and object relationships. Who owns who has access to what from somebody else's properties and methods. So we're going to stop thinking about things that way. Instead, we're just going to start thinking about our code in terms of function input and function output. So instead of being like, this is a class and this class has that thing and this, we're just going to say, this is a function that gets some biz in and returns some biz out. And all I care is the input and the output. And in order to make this work, we're going to introduce the concept of determinism. And so determinism, as I'm attempting to explain it today, is that functions will return the same output when given identical input every time. And without this concept, code ultimately is unpredictable. If you can't guarantee, at least on the function level, right? If you can keep the amount of, if you can keep the scope and the environment that you're in your head, then you can predict what's happening. But if you're looking at the function itself, you don't have enough information to predict what happens. And my claim is that unpredictable code requires wizards and spells to maintain, which is fun, but introduces a lot of technical debt. And predictable code can be maintained by ordinary humans, just like me. I do it for a living. Most of the time, pretty good. And so what do I mean by immutable? We're going to stop thinking about modifying existing objects and data structures. So if you go back to the monsters level up function, it said, we said like this dot monster dot level equals this dot monster dot level plus 1, right? So we grabbed the instance and we set it back on itself using its value, but we reused what we had, right? And so once we changed that level for me, it changed it for Drake. And instead of doing that, changing it in place, which is what I mean by mutation, we're actually going to be creating new objects and data structures based upon the values that we're using. And so now we're going to talk about how to do this a little bit. Cool thing about primitives in JavaScript, they're already immutable. And so if you're thinking right now, like, immutable, this sounds like a scary word. You're already used to working with immutable things. And so every time you use a primitive, you can't modify a JavaScript string in place and keep it in, and see that change in the similar way that we experienced the object mutation earlier. And so we're just going to start thinking about using objects and arrays like we already use strings that are built in. So the first thing we're going to talk about is object.assign. And I've got some examples here, but we're actually going to jump back into the code a little bit. And I'm going to switch up my web pack. Or actually, we'll let this go for now. So object.assign. Object.assign is our go-to whenever we want to modify, whenever we want a modified object. And so here, we're back in here. I've got me, let's go ahead and we're going to capture monsters into me.collection.monsters. And so we've got monsters is going to be an array of 4 monsters, and me.collection.monsters is going to be an array of 4 monsters. And right now, we've got 2 variables, but they're still pointing at the same array, right? And so if I do variable monster equals monsters 0, it kind of feels like I've got a new thing, right? But if I do monster.name, is this big enough, or do I need to bump this as well? Okay, so that was like the funniest joke I've made all day. Is this big enough? Like, it's clearly, it couldn't be bigger. It's ludicrously large. Okay, so monster.name is going to be Bazam. Okay, and so we think we're okay. Monster, Bazam. But if we go and take a look at me.collection.monsters0, it's also been modified, right? And so what we need to do is, if we want to grab it ourselves, we need to create a new object, grab the properties from the object that we already have that we want, and overwrite them with the new properties. So instead, what I'm going to do is we'll change this back, and we'll use object.assign, and we'll say variable assignee equals object.assign. And this is very important. First, to spell it correctly. In code, I don't know if y'all know this, in coding you have to spell things right. But so we're going to pass in an empty object. And this empty object is very important. If we leave this out, we're going to have a problem. And then the next argument is the thing that we want to modify. And so this is going to be monster me.collection.monsters0. And then we're going to pass in now an object that has the property name and the new name. Best name ever. Okay. And so now if we do assignee.name, got best name ever, monster.name, still Bazam, me.collection.monsters0.name, we're all good, right? We were able to use object.assign to get only what we needed, repeated from the object that we used, and then we gave it a new name without mutating our original object or the object within the collection. Object spread. This is an example of one of the techniques that has a little bit spottier browser support. So if you're using this without some kind of transformer and you run into problems, double check that. Make sure the browser that you're using supports the feature the way you expect. But basically, we can use this the same way as object.assign. And the 3 dots here just represent all of the properties of the object, and then after that we can pass in comma-separated lists of new values that we want to add or other values that we want to change. And honestly, that's pretty much all. That's pretty much all you need to be dealing with single objects. And the only thing that I want to emphasize right now, as we move on to arrays, is that once you are dealing with arrays, you need to keep track of 2 things: that the method that you're using on the array itself is not a mutator, and the method that you're using on any objects inside the array is not a mutator. And that'll become a little bit more obvious, but I think that's the most common issue that I see people starting to play with this stuff, is they're like, oh, I'm using a safe method on the array, and like, but when no one was looking, you mutated all your objects in the array. And so take a look at that if you start running into issues. Okay, so map. Map is available on the array prototype, and this is your tool if you want to end up with an array that has the same number of items but has those items modified in some way. And they can be barely modified, just have a single little key or value changed, or they could turn into a completely new type of data. It could be an object to a string. It could be an object to nested arrays. It could be anything, but just so long as the top level array that you're working on has the same number of elements when you're done, map is your go-to friend. And so let's go ahead and take a look at a little map example here. So I've got me.collection.monsters still available, and I can see that it's an array, and so I've got this map on here. Map's going to accept a single argument, and that argument is going to be a function that is going to be applied to every single element of the array. So if I wanted just a variable to, like, a function to, if I wanted a list of names, I could do something like variable monster name is going to be a function. It's going to take in a monster, and it's just going to return monster.name. Okay, so I could apply this to a single. I think I still have monsters. Yeah. Or actually even monster. I can apply this to a single guy or gal and get a name, or I can go ahead and map over all of these. And so I can do me.collection.map and do the same thing. And kind of, it works a little bit backwards visually, but I pass in the function name. Oh, perfect. And we see we get a new array, and it has individual items that are strings instead of objects. Okay. Next, we are going to talk about filter. And filter is just going to be your tool when you want a subset of the array that you're working with. Works kind of the same way. Once you get map, filter becomes more intuitive. You pass in a single function. That function is applied to each of the elements of the array, and you get a new array that only has members that satisfy the expression of the function. And so for this, I can take my names and do filter, and I can pass in here just an anonymous function. It's going to take in a name, and it's going to return name equals Gazy. And I get now a single item because only one of these elements returns true when it's compared to Gazy. So we're going to go ahead and take a look at next up, reduce. Reduce is my jam. I love reduce so much. And the way that I've settled on explaining when to look for reduce, it's so powerful that it's kind of hard to pin it down. But what I focus on is when I have an array and I want to transform it into a completely new thing, then reduce is what I look for. Some more concrete examples are, what if I had a list of objects that had a number property and I wanted to get the sum of that number? I have an array of objects that is coming in, and I have a number that's coming out. They're two totally different things, right? Basically, whenever I see I've got something that is listy and I need to make it something totally different, reduce. So let's go ahead and take a look at this. We'll try to come up with a good example. So I've got monsters, and one thing that happens a lot is you have your data in one type of structure and you need it to be in another. And so imagine that this array wasn't what we wanted. Let's say we wanted instead an object that had, what should we do? Let's just say, I'm going to keep this simpler than I'd intended because I'm nervous. But we're going to just go ahead and we're going to concatenate the strings. So that's a totally different thing. And so we're going to go monsters.reduce. And this, the function that comes into this reduce function is a little bit different, but it takes two things: an accumulator, which is a representation of the new thing that you're building up as you go, and basically a current item. And what we want is accumulator is going to be a string, because that's what we're ending up with. and we're going to add current.name. We're not going to worry about spaces. And then we're going to need an extra thing there. And this is looking pretty okay. And then the next argument that this gets is going to be what gets used for the accumulator the first time this function runs. And if you omit this argument, it's just going to use the first element of the array. Let's see if I got that right. Yeah, so our array turned into a string. But you can do things like you can take an array and turn it into something that looks more like a map. You can take an array and turn it into a single big object with a million different keys. You can do all kinds of things. And almost a lot of times now when I look at code that says, I had this big list of things, I'm going to do a bunch of fors over it, and then I'm going to end up with this new thing at the bottom. I'm like, oh, actually, we can just take that, flip it on its head, use reduce, and things are fun. So the last thing is that we do have a spread operator on the array. Since I'm running out of time, we're just going to say it's another way to kind of grab up the elements of the array and return a new array without repeating. And so now we're going to take a look finally at our final code. And so we've got some requirements here now. We've adjusted. We're going to focus on input and output. We're going to leverage immutability, and we're going to achieve determinism. And so same thing, I'm going to start out by sketching what my plan is before I jump into the keyboard. And so here I've got function names, the input that I'm expecting, and the output that I'm expecting. And so you can imagine that when you're trying to solve a problem this way, it really is a different paradigm than when you solve the problem the other way. It's not just using these tools or techniques, right? You need to also say, hey, I'm approaching this completely differently. If I try to program functionally in object-oriented land, I'm not going to be a happy camper. And if I try to do vice versa, it's going to be the same, right? And so I've got a trainer, which is going to take in a name and alignment, and it's going to return an object that has name, alignment, and collection. I've got level up. It's going to take times and a monster, and it's going to return a monster that's been leveled up that many times. And I've got battle, which accepts trainer 1 and trainer 2 and returns a string. And functional, deterministic, immutable, rainbow land. Love it. Okay, so let's go ahead and take a look at some code with the army of Pikachus powering us on. Okay, so now we're going to have to switch over Webpack. And run it again. Cross all our fingers and toes. Let this fly. Get rid of our meaningless breakpoints now. Okay, good. So we're kind of back to where we started at the beginning, right? We're rendering our little header, and we're going to try to use some immutable patterns here. And so we're catching cute monsters with immutable patterns. So same thing. Let's go ahead and take a tour of some of this code. Okay. So real quick, we have a trainer right here. And this looks remarkably like our sketch, right? Name, alignment, collection with starter monsters coming in. We've got a battle. A little bit more complicated because we have to sum, but we're leveraging reduce here instead of those nested for loops. And we've got level up, simply a function, takes in times and monster and does that. And so now, really quick, in the final 2 minutes, coming in clutch, we're going to go ahead and that was like a legit sports joke, which shows you how nervous I am. Okay, so we've got index right here. And so we're going to do the same thing. Const me equals trainer. Trainer is going to be a function that's going to take in a name, which is going to be Ryan, alignment, evil, and then const Drake is also going to be a trainer, and it's going to be Drake and good. And then we're going to say const, we're going to render. render. Boom. Okay, we got some stuff. And then we are going to say Drake.collection equals Drake.collection.map. And we're going to get a monster. And we're going to return level up, monster, and times 3 monster. Boom. Drake's got more. And then finally, we're going to render and we see that balance is restored. Drake rules, Ryan drools. Thank you very much.